Hi everyone, let's do this question. This is a question which I have created based on the questions given in the GMAT official advanced questions book. So let's go ahead and read this question. The nth term in a series is defined as 1 plus 1 divided by n plus 2, where n is equal to 1, 2, 3, etc. Is the product of the first x terms in the series an integer? So that's the question. And we're given two statements. X is a multiple of 3. X plus 1 is a multiple of 2. Alright, and again remember, you don't need to solve the question, you just need to have a definite yes or no based on the given statements, and that's how you can choose either A, B, C or D or E, and that's common for any data sufficiency question. Now pause the video, give it a try, and then let's try to solve this question together. Alright, we are back. I hope you have given it a try. Now again remember, if you have not yet subscribed to this channel, please do subscribe and support us so that we can continue bringing you good content. Now let's go ahead and solve this question together. It's given that the nth term of the series is 1 plus 1 by n plus 2. Alright, now let's just write it as an, which is the nth term, and it's given as 1 plus 1 by n plus 2. And we need to find the product of the first x terms in the series. Alright, so that would be a1 into a2 etc. up to ax. Now let's just try and observe whether there is a pattern over here. Now what would be a1? A1 would be when n is equal to 1. So that would be 1 plus 1 by 3, right? 1 plus 2 gives us 3 over here, and 1 plus 1 by 3 is equal to 4 by 3. Now what about a2? A2 would be 1 plus 1 by 4 because n would be equal to 2, right? And that would be equal to 5 by 4, alright? Now again, in a similar manner, you can see that a3 would be 6 by 5, right? So over here you have 4, then you have 5, and then in a3 you would have 6. Similarly, over here you have 3, then you have 4, and in a3 you would have 5. So 6 by 5 would be a3. Now if you want to take a look at this product over here, that would be 4 by 3 into 5 by 4 into 6 by 5, and then it goes on like that. Alright, and the last term, let's say it's the nth term. Alright, so the last term would be n plus 3 divided by n plus 2, right? Why is that so? Over here you can see, right? If we simplify this, this becomes n plus 2 plus 1 divided by n plus 2, and that's equal to n plus 3 by n plus 2. So that would be the last term or the nth term, and based on this pattern, the previous term, the numerator would be 1 less than what we have over here, and the denominator would be 1 less than what we have over here. So that would be n plus 2 divided by n plus 1. And then the previous term to this would be n plus 1 divided by n. So this would be the product, right? Now, if we take a look at this, you can see that there is an interesting pattern over here, right? We have 4 over here and we have 4 over here. So these will cancel out. We have 5 over here and we have 5 over here. These will cancel out. Similarly, you can notice over here we have n plus 2 and we have n plus 2 over here. So these also cancel out, and that's the same thing that we can see over here as well. So over here we have these numbers cancelling out, and this 6 and whatever comes after that would also get cancelled out, and this n would cancel with what is over here as well with the previous number, right? So we will be ultimately left with n plus 3 divided by 3. And again, over here we have the first x term, so that would be x plus 3 by 3, right? So again, that's the same thing, and we just need to know whether this value over here is an integer or not as per the question. Now let's take a look at the statements which are given to us. The first statement says x is a multiple of 3, and again we can write this as x plus 3 by 3 if it's a of x, right? So a of x would be 1 plus 1 by x plus 2, and again instead of n over here you would have to just write x. So we have to just find whether x plus 3 by 3 is an integer, and as per statement 1 it says x is a multiple of 3. Now if x is a multiple of 3, x plus 3 by 3 will definitely be a multiple of 3, right? And then if you divide that by 3 you will get an integer, right? So yes, statement 1 alone is definitely sufficient. So yes, we have a definite yes. Alright, now what about statement 2 alone? It says x plus 1 is a multiple of 2. Now with this statement, can we find whether x plus 3 by 3 is an integer or not in a definite manner? Let's try. If we take x as 3, right? If we take x as 3, x plus 1 is 4, and yes, this statement over here is sufficient, is valid, but in that case this is a yes, right? So if you are taking x as 3, we are getting a yes. Now if we take x as 5, In that case also x plus 1 is a multiple of 2 because 5 plus 1 is 6 and 6 is a multiple of 2. But in that case, this over here is not an integer, right? So sometimes we are getting a yes and sometimes we are getting a no. So statement 2 alone is not sufficient. So therefore, the correct answer to this question is option A, which is that statement 1 alone is sufficient, but statement 2 alone is not sufficient. All the best in your preparation.